Welcome. We're going to continue to look at section 3.2 and looking at a sampling distribution. So if you had access to a sampling distribution, how would you find the margin of error? So we're looking at confidence intervals, margin of errors, interval estimates, and you want to make sure that your intervals have the form your statistic, whatever it may be, plus or minus a margin of error. And we want to make sure to capture the parameter for 95% of all samples. So what was the 95% rule from chapter 2? So if we have a symmetric and bell-shaped distribution, so we need to have a big assumption. If the sampling distribution is approximately symmetric and bell-shaped, 95% confidence interval can be estimated using the statistic plus or minus 2 times your standard error. Remember, this comes from thinking about 2 times your standard deviation gives you 95% of your data. Excuse me. So that's where this formula comes from. We're doing an approximation. Later on in chapter 6, I believe, we'll come back and get a little more precise about this. But right now, I want you to have the idea that 95% of your data, if you have a symmetric and bell-shaped distribution, is within those 2 standard deviations of the center, which is the statistic. So let's take a look. A survey of 1,502 Americans in January 2012 said that 86% consider the economy to be a top priority for the President and Congress. And the standard error for the statistic is 0.01. With this information, what is the 95% confidence interval for the true proportion of all Americans that consider the economy a top priority at the time? The answer is B. Okay, more importantly, how did we get 48 to 88%? Well, again, we're going to take, for 95% confidence interval, we need to double the standard error. So that is your margin of error, is 2 times your standard error. So 2 times 1% gives me 2%, and we're going to add and subtract that to 0.86 to get this confidence interval. In a random sample of, I'm going to say people from Quebec, 28% thought Quebec should secede from Canada. If we use this sample statistic, this p-hat, 28%, to estimate the true proportion of Quebecers who think Quebec should secede, the margin of error is 4%. So from this information, a 95% confidence interval for the true population proportion is? The answer is D. So the difference between this question and the last question, the previous question, we were given the standard error. So we had to double it to get the margin of error. In this example, we're given the margin of error. So we need to take 28% and subtract and add 4%. So subtracting gets me 24, adding gets me 32%. So make sure to pay attention. Do we know the standard error or the margin of error? So in a random sample of Quebecers, 28% thought that Quebec should secede. So the same data as before, our confidence interval is 24% to 32%. How many of the following are plausible values for the true proportion given the confidence interval? And that would be 2. The confidence interval was 24 to 32%, and we've got 28 and 30 are in that interval. Okay, so this, I think, might be the hardest part of this section, is interpreting confidence intervals. And I'm going to take this to be very important. What exactly is a confidence interval? So 95% of all samples yield intervals. Every time we take a sample, we could then construct an interval. And 95% of these samples will contain the true population parameter. So we're going to say 95% sure or 95% confident that one interval contains the truth. So we're 95% confident that the true proportion of all Americans that consider the economy a top priority in 2012 is between 84 and 88%. All right, let's go through an example. Scientists hoping to curb deforestation estimate that the carbon stored in tropical forests in Latin America, Sub-Saharan Africa, and Southeast Asia has a total biomass of 247 gigatons. So they first estimate the mean amount of carbon per square kilometer. So they did a sample size of 4,079 plots, got a sample mean of 11,600 tons, and a standard error of 1,000 tons. So keep in mind, the standard error comes from if we could do many samples of 4,079 and plot all the means of all those different samples of 4,079, the standard deviation of the sampling distribution of all those samples would be 1,000. So from this information, let's give and interpret a 95% confidence interval. So the 95% confidence interval, CI, is taking the mean, the point estimate, 11,600, and we're going to add and subtract 2 times the standard error. This is the way to approximate a 95% confidence interval. So we're going to add and subtract 2,000 to get 9,600 and 13,600 as our confidence interval. Now, how would we interpret or write or summarize what this means? We'd say we are 95% confident or sure. We could change this confident for sure. But we're 95% confident that the average amount of carbon stored in each square kilometer of tropical forest is between 9,600 and 13,600 tons. I'm definitely going to ask you to interpret confidence intervals. So using the correct terminology, 95% confident that the average amount of carbon stored. So we're 95% confident about the population parameter. And notice we include units. So we have an average here, but I want to know what average are we talking about. Okay, let's say we want P to be the proportion of time a coin lands heads if you flip a coin. So P is going to be the population parameter. And assuming we have a fair coin, we know P is going to be 0.5. Should be 0.5. But let's pretend that we don't know that and we want to estimate it. So one way we could do that is to flip a coin, say 25 times, and compute a sample proportion. So I could have each student in a class of 30 do this, and I would get a sample of 25 times, but I'd have 30 samples if I had 30 students do this. So we're not going to go through this since it's a video, but suppose 30, 40, or 50 students flipped a coin 25 times, recorded their sample statistic, their p-hat. And if you want to create a 95% confidence interval based off your specific statistic, what percentage of your intervals do you expect to include the true p? So maybe instead of your, think of all the classes. We're doing many different samples. How many or what percentage should include the true population parameter? 95%. 95% of the intervals should contain the true population parameter. In this case, it'd be 0.5 for flipping a fair coin. Okay, we'll go through which of the following is an appropriate interpretation for a 95% confidence interval. We are 95% sure the interval contains the parameter. There is a 95% chance the interval contains the parameter. Both A and B or neither A and B. All right, even though A and B look very similar, answer is A. We can't make probabilistic statements such as B, there's a 95% chance, because the interval either contains the truth or it doesn't, and also that 95% pertains to all of the intervals, all of the samples, not just the one we created. So we can't talk about your one specific interval containing a parameter as a 95% chance. That's why we say we're 95% sure or confident. Okay, so I'm going to wait till the next video to talk about common misinterpretations of confidence intervals.